This is Euclid Book 9, proposition number 13. And well, first of all, here's the diagram. There you are, folks. Okay. If as many numbers as we please beginning from a unit in continued proportion and the number after the unit be prime, the greatest will not be measured by any except those which have a place among the proportional numbers. Yeah, right. Okay. Let there be as many numbers as we please, A, B, C, and D, beginning from a unit and in continued proportion, and let A, the number after the unit, be prime. Okay, so basically we have a unit, A is a prime number, and it's as A is to B, so as B is to C, and C is to D. Okay. I say that D, the greatest of them, will not be measured by any other numbers except A, B, and C. For if possible, let it be measured by E, and let E not be the same with any of the numbers A, B, and C. Okay. So we're saying that E is going to be measured, well, hang on. We're going to say that D will be able to be measured by E. E will measure D. Okay, that's what we're saying right now. And let E not be the same with any of the numbers A, B, and C. It is then manifest that E is not prime. For if E is prime and measures D, it will also measure A, which is Euclid Book 9, proposition number 12, which is prime, though it is not, which is impossible. So in other words, since we said that E is not prime, it would be prime because it would measure, it would be the same as A, and we already know A is prime, so E is definitely not prime. Okay. Therefore, E is not prime. Therefore, it is a composite. But any composite number is measured by some prime number, which is by Euclid Book 7, proposition number 31. Therefore, E is measured by some prime number. I say next that it will not be measured by any other prime number except A. For if E is measured by another, and E measures D, the other will also measure D. So that it will also measure A by Euclid Book 9, proposition number 12, which is prime, though it is not the same with it, which is impossible. Therefore, A measures E. In other words, if there's another number that measures D, it's going to be equal to A, and therefore, it's going to be impossible. And since E measures D, let it also measure it according to F. So in other words, E times F is going to make D. Okay? E times F makes D. Got it. I say that F is not the same with any of the numbers A, B, and C. For if F is the same with one of the numbers A, B, and C and measures D according to E, therefore one of the numbers A, B, and C also measure D according to E. But one of the numbers A, B, and C measure D according to the sum of one of the numbers A, B, and C, which is Euclid Book 9, proposition number 11. Therefore, E is also the same with one of the numbers A, B, and C, which is contrary to the hypothesis. Whoa. Therefore, F is not the same as any one of the numbers A, B, and C. Similarly, we can prove that F is measured by A by proving again that F is not prime. For if it is, and it measures D, okay, now we're saying if F is prime and it measures D, then we had a problem with A. Okay? Because F would also measure A, and we all know that can't happen because of Euclid Book 9, proposition number 12, and that's because it's prime, though it is not the same with it, which is impossible. Therefore, F is not prime, therefore it is a composite, but any composite number is measured by some prime number, which is by Euclid Book 7, proposition number 31. Therefore, F is measured by some prime number. You think you can endure more? Let's go for it. I say next that it will not be measured by any other prime except A. Okay? So F cannot be measured by any other prime number except A. Okay? For if any other prime number measures F, F measures D. In other words, if a prime number measures F, F will then measure D. And that could be a problem. That other will also measure D. So if the other prime number that's measuring F will also measure D. So that it will also measure A. Because if that prime number is measuring F and F measures D, then therefore that prime number will also measure A by Euclid Book 9 proposition number 12, which is prime, though it is not the same with it, which is impossible. Therefore A measures F. And since E measures D according to F, therefore E by multiplying F has made D. Therefore E times F makes D. Okay. But further, A has also by multiplying C made D. A times C makes D. That's by Euclid Book 9 proposition number 11. Therefore the product of A and C is equal to the product of E and F. Therefore proportionally, as A is to E, let's see. Okay. As A is to E, so is F to C. As A is to E, so is F is to C. And this is by Euclid Book 9, Euclid Book 7, proposition number 19. But A measures E. Therefore F also measures C. Let it measure it according to the units in G. Okay, so now, because A measures E, therefore F measures G according to the units in... No, I'm sorry. F measures C according to the units in G. Similarly, then, we can prove that G is not the same with any of the numbers A and B, and that it is measured by A. And since F measures C according to the units in G, therefore F by multiplying G has made C. F times G makes C. Okay. But further, A has also by multiplying B made C. A times B is C. That's by Euclid Book 9, proposition number 11. Therefore, the product of A and B is equal to the product of F and G. A times B equals F times G. Okay. Therefore, proportionally, as A is to F, so is G is to B. A is to F, G is to B. Okay, this is by Euclid Book 7, proposition number 19. But A measures F. Therefore, G also measures B. Let it measure it according to the units in H. Wow, this proof's getting big. Similarly, then, we can prove that H is not the same with A. And since G measures B according to H, G measures B according to H, therefore, G by multiplying H has made B. G times H makes B. Wow. But further, A also has, by multiplying itself, made B. Okay. A times A makes B. And this is by Euclid Book 9, proposition number 8. Therefore, the product of H and G, H times G equals the product of A times A. Therefore, H is to A as A is to G. H is to A as A is to G. Okay. This is by Euclid Book 7, proposition number 19. But A measures G. Okay? Therefore, H also measures A, which is prime, though it is not the same with it, which is absurd. Therefore, D, the greatest, will not be measured by any of the numbers except A, B, and C. Aren't you glad that proof's over? Okay. I will tell you more in a future video. Stay tuned.